Okay, so a little bit more about using buttons. So this is kind of the basic circuit you just set up, and you had it connected to the serial monitor. And so what was happening was that you had a 5-volt connection here going through a button and into a digital input where we're reading the value. And what would happen if you close this button, it's going to send that 5-volt signal. But what you might notice is when you release the button, it doesn't drop back to 0 right away. It's going to kind of bounce around maybe, and it doesn't really know where to be. And the reason why is because we haven't kind of removed the voltage. So even though we had sent it there, it can kind of like, if there's nowhere for it to go, it's going to kind of, basically it'd be like, maybe if there was like a, I don't know if this is exactly what's going on, but if there's like a charge there, the charge would kind of start to dissipate and would eventually go away, but wouldn't go away right away. Now when you hold down a button, you probably want one thing to happen when you hold it down and something else to happen when you release it. And so we can end up with kind of a tricky situation here when we want it to just shut off when we release the button, but it's not. Okay, and so what we can do is use something called a pull-down resistor. And we're going to use this with a lot of inputs to prevent situations like this. And basically what we can do is we can say, okay, this circuit will be connected to the ground pin when we're not using it. Okay, so G and D. Okay, but you'll notice if it's connected here, when we close the pin, we're going to short out to the ground pin. We're going to create a short, and none of the current's going to go that way anyway. And so what we do here is we actually put a resistor here so that like a slow amount of current goes this way, so that when we're not holding the button down, this is connected to ground, and so there's no voltage here. Okay, and then when the circuit is closed, this is going to flow to that input, and then it will send a tiny bit of current that way, but we're not shorting it out anymore. Okay, and so this is kind of the way around that. And so we want to use a high amount of resistance so we don't have a lot of current flowing this way. And so we're going to use 10 kilo ohms here. Okay, and what this is called is called a pull-down resistor. And basically the goal is to ensure that there's 0 voltage here when there isn't supposed to be any voltage. Okay, and so when we push the button to turn this circuit on, basically, or to make this on, then when we release it, we want an off, and this ensures that it's off. Okay, and there's other variations of this in which we use a resistor instead of a pull down. So this is a pull down resistor. If you were to switch the 5-volt in the ground here, you could use it as a pull up resistor. So we're not going to really run into this that much, but you could imagine a scenario where this whole thing is reversed and you have a button that's connected, and we want to check to see when the button is low, and then we have it pull up to the 5-volt pin to keep it high when that button's not pressed. Okay, again, this situation would be less common, but in this case it would be called a pull-up resistor instead of a pull-down, because in this case we're taking that pin and we're pulling the voltage up high, and in this case we're taking that pin and pulling the voltage down low. Okay, so that's called, as I said, a pull-down resistor, and it's something that can avoid tricky situations coming up. Also, while we're at it, I just want to mention, if we're going to graph voltage, let's say this is 0 volts and this is 5 volts. When you press a button, this is like voltage over time. When you first press the button, the voltage is going to kind of like bounce when you first press it, and when you release it, it's going to bounce again, kind of, before it goes down to low. And this is just the time in which you're pressing it and the time in which you're releasing it. It doesn't happen instantly. It takes some fraction of a second to happen, and it creates this noise. Okay, here we have the high signal 5 volts, here we have this noise, and here we have this noise. And so the way that we correct for this is by adding a delay into the loop, so that it's going to wait a little bit before it checks again. So like you might have it switching on and off really fast because you waited from here to here and kind of avoided that mess. Same thing going like from here to here. If you have the delay, you can kind of avoid that mess and jump right from high to low. And if it's like a short delay, 100 milliseconds is enough, and generally that's short enough for whatever purposes you need, but long enough to allow for that to take place. Okay?